Hi math students, and welcome to your lesson on horizontal and vertical lines. In this lesson, we are going to be learning how you graph horizontal and vertical lines and how you write equations of those lines. I real quickly want to review the two words I'm saying, since nowhere in the lesson do we specifically say what they mean. Horizontal, do you remember what a horizontal line is? Horizontal lines are those flat lines. I've heard the trick, think about the horizon on the sky is a flat line, and so is a horizontal line, which means vertical lines are those lines that go up and down. So this right here is a vertical line. Now we saw these two lines at the very beginning of this unit. That first lesson was an introduction on slope, and we talked about these two lines there, but since that lesson we haven't really seen them. Pretty much all of the lines we've been looking at are lines that go up on your graph from left to right or lines that go down. So we've learned how you graph those lines, how you write equations of those lines. To finish up learning about linear equations and to help you become a linear equation expert, we need to talk about these two last sets of lines. To begin, we've got just a quick couple notes we're going to take down on each of these. Our horizontal lines, which we said look like this. The slope of these lines is something we already learned, so I want to see if you remember. Do you remember what the slope of a horizontal line is? Well, we had said lines that go up are positive, lines that go down are negative, and between positive and negative numbers is the number 0. So a horizontal line has a slope of 0. Because it's not going up, it's not going down, it's just 0. With our lessons today, horizontal lines, when you see the equation, it's going to look a little different because the equation is only going to have a y in it. This is something we're going to talk about more in just a moment. Now our other lines, vertical lines, we also learned what the slope of those lines look like. What is the slope of a vertical line? Well, when we had talked about this in that first lesson, we said pretty much everything is positive, negative, or 0, right? All the numbers we have in math, positive numbers, negative numbers, and 0 numbers. There's nothing left. For a slope of a vertical line, we say vertical lines have an undefined slope. The slope of a vertical line is undefined. That means there is no number we can use to define the slope of this line. If you think about it, I've heard some people make sense of it with positive slopes are lines that if you're walking up them, you're walking up, hence positive. A line with a negative slope, you're walking down, so negative slope. 0 slope means you don't have to go up. This is like going upstairs, this is going downstairs. 0, there are 0 steps you're going up. Something like this though, you can't walk up a vertical line. It doesn't make sense. It's another trick you can use to remember it's undefined. Now for our vertical lines, the equation is also going to look different because it is only going to have the variable x in the equation. So these are going to be things that let you know it's going to be a vertical or horizontal line because all of our equations up to this point have had x and y in them. I'm going to erase this and we'll go ahead and start looking at some examples. The first problems here say create a table and write an equation for the graph of each line below. And we're starting with this graph here. I'm not sure if you can see it clearly because it's like a light gray color, but this line right here is the line they're asking us to create a table for and to write an equation of. I'm going to start with that table. If you're ever trying to write a table from a line in a graph, all you're going to need is to pick out some points that are on the line. So for example, I could start right here with that point in the middle of the line. That's at our y-intercept. If I want to write the point for this, I need to see where the point is on our x-axis. That would be at the number 0. And then where that point is on our y-axis, well, that's at the number 2. You can pick out more points, so maybe I want to do this one next. The x-coordinate for that point is going to be 1, and the y-coordinate is 2. I could keep going. Let's do this point here. That x-coordinate of this point is, the x-coordinate is the number 2. And then the y-coordinate of that point, same thing as all those other ones. It's going to be 2. You can pick any point in the line. Maybe let me pick one over here. I'm going to pick this one. The x-coordinate for that point is -3. And that y-coordinate is going to be same as all the other ones. We get 2. And there's lots more points on this line. These arrows mean this line goes on forever in both directions, which means there's lots of more points in those directions. Just want to pause and look at the table. Is there anything you notice about the points we filled in our table? Well, hopefully you're saying, oh, I notice every single time that y-coordinate is 2. That is going to be important for the second part where we go to write an equation of our line. Now, normally when we are writing an equation of a line, there's a formula we always use. We usually use slope-intercept form, or y equals mx plus b, to help us write equations. When you're looking at a graph, there are 2 things you'll always be able to find. That's your slope and that's your y-intercept. So looking at this graph here, I could find my slope and my y-intercept and use that to write the equation of a line, same as all the other graphs we've done. Well, if I were to do that, we've already figured out our y-intercept. It was one of the points we picked. It's this number here at 2 because that is where our line crosses our y-axis. So I know it'll say plus 2 there. To finish this up, I need to find the slope of my line. We've got a horizontal line here. What is the slope of this line? Well, we said it a moment ago. It's a horizontal line. That means the slope is 0. When I fill in 0, it's going to say y equals 0x plus 2. Now that's okay, but that's definitely not how you're going to see it because there's something else we can do there. Remember, when you've got a number next to a variable, that means multiplication. 0x means the same thing as 0 times x. 0 times anything is 0. So that means this part right here really just means y equals 0 plus 2. Notice right there, we have no more x now in our equation. This also is not the simplest way to write the equation. Instead of saying 0 plus 2, we can just say y equals 2. This right here is the final equation for this line. This is the line y equals 2. Now I know we've got the equation, but I want to pause here and talk through some things. One of the things you might have noticed in our table is that our table, it didn't matter what that x-coordinate was. Every single time, that y-coordinate was 2. That helps make this equation here make sense. This equation is saying it doesn't matter what you put in for x because y is always going to be 2. Now, when you're looking at a graph of a line like this and trying to get an equation, you can do this every single time if you want. There's nothing wrong with that. But the quickest way is just to see, okay, it is crossing our y-axis. This is our y-axis. It's crossing our y-axis at 2. Every single point here has a y-coordinate of 2. That must mean our equation is y equals 2. This is one example. I've got another one for us. There we go. Already saw this. This time I'm going to have you start the table. Go ahead and tell me a couple points that are on this line right here. All right, again, there's tons of points you could have put. A possible one is, let's start right here. That would be negative, let me count. 1, 2, 3, 4, yep, negative 5 on our x-axis. And then that y-coordinate is 2. There's also a point right here. That's going to be negative 5 on our x-axis, and the y-coordinate will be 1. There's a point right here. That's negative 5 on our x-axis, and the y-coordinate 0. And then I'll pick one down here. We could do that one. That's going to be negative 5 on our x-axis, and then a negative 2 for our y-coordinate. Looking at all of these points here, go ahead and make a prediction. What do you think the equation of this line is going to be? Well, let's see if your prediction is correct. If I went to write the equation of this line the same exact way I did before with slope-intercept form. What is going to happen? We've got y equals, m is our slope. We've got a vertical line. Do you remember what the slope is of a vertical line? It's undefined. Undefined isn't a number I can write here. I'm not going to write y equals undefined x. That's not how this works. It also wants a y-intercept. But look, this line does not cross your y-axis. There is no y-intercept. What it means is this formula isn't going to work to help us get this equation. The reason this formula doesn't work is because this formula says y equals something. And the problem with that is this equation isn't going to have y in it. If I look at this table, similar to the one we just did, what do you notice all of these have in common? Well, usually, students will say, I notice they all have the x in common. Just like the one from before, our equation's only going to have one variable. This time it's going to say x equals -5. This line right here shows all the different points that have an x coordinate of -5. Now, if you were writing an equation of this line without a table, what I would say is we'll see where your line crosses. Our line passes through that x-axis, so that helps me know it's going to be x equals, and it passes through our x-axis at -5, which is another way you can get the equation x equals -5. I'm going to go ahead and erase all this. We've got, whoops, sorry. This will be the first practice one, similar to what we were just doing. It says create a table and write an equation for the line in the graphs below. This is the first one. And this is the second one. All right. So for all the ones we just looked at, this was them giving us a graph and us writing the equation. We're going to practice the same thing just in reverse. This time, we're given the equation, and we need to draw the line of the graph. Now this, if you're feeling good on that first part, sometimes in class, like I don't even need to show this because students are like, oh, it's just like the same thing. If you wanted to graph this, you could, if you want, create a table and just say, it doesn't matter what x is, just every single time my y is going to be -2. It doesn't matter what x is, you could put any numbers there, but just make sure your y is always -2 and use that to help you graph. The way I like to do it is, if my equation is y equals, I know it is crossing through my y-axis. That is right here. And then if it's y equals -2, it means it's passing through my y-axis at the number -2. So I could find -2 on my y-axis. That is right here. And we want the line to intersect the y-axis at -2. We want it to go through that line, not on top of your y-axis, but cross through it at -2. So that would be a horizontal line like this. You could do the same thing for the next one, x equals 3. Well, that x equals tells me a couple of things. It tells me it's a vertical line. It tells me it's crossing our x-axis at 3. So I could do the similar thing to this one. Could go to my x-axis at 3. That's 1, 2, 3. And then I want to draw a line that's passing through our x-axis at 3. That intersects at one point, and that one point is 3. That would be a vertical line, like that. I like these because they're like the easiest ones to graph. I don't even need a ruler, just draw a straight line. There are these two similar ones I'm going to have you go ahead and try. We've got the graph of the line y equals 0. And the graph of the line x equals -5. The ones with 0 are usually the ones that trick students a little bit. If it's y equals 0, means your line should be going through this point here at 0. You want it crossing through the y-axis at 0. Not on top of your y-axis, but crossing through it. That would be a line that looks like this. Some students want to do a vertical line instead, usually in class. Sometimes, especially for these ones that begin y equals, it could also help to compare it to our beloved slope-intercept form, y equals mx plus b. If it says y equals 0, that means that y-intercept is 0. And then it also means, since the slope is missing, that the slope is 0. So we want our y-intercept to be 0, and then we want a 0 slope, which would be that horizontal line. X equals -5 is a little easier. It's 1, 2, 3, 4, 5. It would be a line that looks like that. Now the last couple problems we're going to look at are just what I think are really fun problems, just different ways you can see the same skill asked in a question. So the first one says, graph the following lines. What is the difference? And the first one says y equals -3. And then the second one says y equals -3x. Well, this first one here, y equals -3, this is the same thing we've been doing. I look at that equation, I see only one variable. That gives me a clue it's going to be a horizontal or a vertical line. Y equals -3 means it's crossing our y-axis at -3. So I'm going to go down to -3. And if it's crossing through our y-axis, if my equation is y equals, all of that tells me it's going to be a horizontal line. Now the second one, y equals -3x, is a little different. Notice we've got both variables here. This is a linear equation like the ones we were doing earlier in this unit. It's a diagonal line. It's going to have like a positive slope, a negative slope, one of those, and it's going to go diagonally across the graph. This is not a horizontal or a vertical line. I know that because I can compare this one to y equals mx plus b. And if I'm looking at that, I can see, okay, this one has a slope of -3. That means it's not horizontal or vertical. It's going to be going down across my page because it's negative. If I'm also comparing it to slope-intercept form, that's helpful because then I can also see our y-intercept is going to be 0. There's no number written here. That means the y-intercept is 0. So when I go to graph this one, our line crosses through the origin at 0, and then the slope is -3. Remember, if you're trying to graph a line like this, you can always use rise over run to help you graph. If our slope is -3, I can rewrite that as a -3 over 1 and also over our run to see that the rise is going to be -3 and the run is 1. So starting here at our first point, we want to go down 3 over 1, down 3 over 1. And we can keep doing that. I can also, remember, do the opposite. So instead of down 3 over 1, I can go up 3 backwards 1 to get more points on the line. So let me do that. Let me go up 1, 2, 3, backwards 1. Up 1, 2, 3, backwards 1. Up 1, 2, 3, backwards 1. And then I've got a bunch of these points on our line. And we get that for that second equation. Once students see horizontal and vertical lines, it's much easier to confuse these equations with horizontal and vertical lines and think this should be like a horizontal line at -3 or a vertical line at -3 as well. I think like the easiest advice I can give is if you only see one variable, that's a clue. It looks different from everything else we've been doing. It's a horizontal or a vertical line. If you see an x and a y in that equation, compare it to slope-intercept form, and that is going to help guide you on what you want to do to graph the line. Now there's one last question with this that says, whoop, I'm sorry. Not with this. There is one last question. The last question says, which equation is parallel to the y-axis? They're asking us about parallel lines. Do you know what parallel lines are? Parallel lines are lines that go in the same direction. An easy trick with parallel that I like to use is notice in the word parallel, there's a pair of parallel lines. Those two L's right there. They go the same direction. So parallel lines, I'll just put a little note here, and if you want to copy it down in your notes, you can. Parallel lines are going to be lines that go the same direction. So when they ask which equation is parallel to the y-axis, what they're really asking is which of these equations goes the same direction as the y-axis. And you can always think of your coordinate plane and your x and your y-axis to help you figure that out. Your y-axis is this line right here. So what do you think? Which one of these is parallel to that y-axis? Well, to help us figure out which one's the correct answer, I'm just going to draw some little pictures out. Y equals 2, that's going to be a line going through your y-axis at 2. So y equals 2 is going to be a line that crosses, let's say that's about 2, and crosses through our y-axis. If I'm comparing this line to our y-axis, that line does not go the same direction. It is not parallel. So that would not be the correct one. We could try another one. Let me pick a different color. We could do this one. Well, maybe that is not the right color because I'm not convinced you can see that on camera. Let's try maybe no greens. We'll stick to black. We'll try this one, x equals 2. That is going to be a line going through your x-axis at the number 2. So here's my x-axis. Here's the number 2. I want a line going through the x-axis. So that would be a line that looks like this. If I check, is that line parallel to the y-axis? Why, yes. Yes, it is. It's going the same direction as our y-axis. So I would circle that one. Y equals x is a line that has a slope of 1 and a y-intercept of 0. That would be a line that starts here, and then the rise over run would be 1 over 1. So 1 over 1, 1 over 1. It's going to be a diagonal line that looks like this. Y equals 2x is similar. It still has a y-intercept of 0, but this time the slope is 2. So you'd be going up 2 over 1. It would just be a steeper line like that. But both of those wouldn't be parallel to the y-axis because they cross through it. Parallel, you got to go the same direction, which means you would never be crossing. What I've kind of sketched here is the last part of the question, which says either use the graph below to explain in words. Either use the graph below or explain in words your answer to the question above. So we said which equation is parallel to the y-axis? We said x equals 2 is. You could either convince me of that by showing me on a graph. Well, x equals 2 is this line right here. The y-axis is this line here. And therefore they are parallel. Or you could give me a written explanation. You could say something like x equals 2 is a vertical line. You could stop right there, or you could say a vertical line that intersects. Intersects just means like crosses or passes through. So you could say it's a line that intersects the x-axis at 2. You could say it passes through the x-axis at 2, something like that. The y-axis is also vertical. So they are parallel. That's one example of how you could explain why your answer is correct. There's lots of options for this. You could also, if you want, instead of saying like vertical and parallel, you could convince me by saying, well, both of these lines go up and down. They never cross. It means they are parallel. You could say the two lines go in the same direction, which is why x equals 2 is correct. Lots of different ways you could word it. This is just one example here. This is the last problem I've got for this lesson. Thank you so much for watching. I will see you tomorrow. Thanks. Bye.